Ready to go from one of these to one of these? Let's get stuck in. Hey everyone, and welcome to another episode. If you are new to the channel, take a second to hit that little subscribe button to get all the latest reviews, tips and tricks and tutorials like you are watching now. A while ago I bought a Spindle and VFD, obviously with the intention of upgrading one of my CNC machines. But if I'm honest, I lost confidence and I just put it to one side and it sat there for quite a while. Well, I finally took the time to do the research I needed, as well as getting the confidence back to get this installed, and that's exactly what I'm going to be showing you in today's video. Now, I'm going to be sort of splitting this into two parts, and there'll be a second video following. The first video which we're doing today is about doing all the main wiring, getting everything installed and set up on your CNC machine. The second part that will follow later is about getting your existing control board to turn the spindle on and off automatically, and obviously control the speed from your software. Now, there are two quick things I do need to mention. Obviously, this does require some electrical connections and soldering. If you are not comfortable doing that type of thing, then either pay someone to do that phase for you or look at buying pre-built kits. Daniel and his team over at PwnCNC sell some pre-built kits that make your life much easier. I'll put some links in the description area below if you are interested in one of those. The second thing I need to mention is, obviously, I'm not an electrical engineer. I'm just a guy who learns things as he goes along, and I've done the best of my ability to make all this safe and correct. But obviously, if you see something that could have been improved in the video, then let me know in the comment section down below. It helps me and it helps my viewers. So with that out of the way, well, let's take a look at all the things you need to get this job done. So let's take a look at the bits we're going to need for today's video. Obviously the VFD and the spindle itself. You're going to need a spindle holder that matches the diameter of your spindle. You're going to need a power cable, obviously, to run all of this. You can make one yourself or just do what I do, which is use what I call a kettle lead, the type of cable that plugs into the back of your PC. Now, to connect the spindle to the VFD, we need a special type of cable. This is 4-core shielded cable, and basically what that means is there's an extra coating on the inside to protect the cables from electrical interference and just make sure that this all runs as smooth as possible. Now, the gauge I'm using on this, it is 1.5mm cable, which I think is 16 gauge. Now, this is suitable for this size spindle, possibly also suitable for a 2.2 kilowatt as well, but do check with somebody more competent if you are unsure what gauge wire to use for your setup. We're going to do a little bit of soldering later on, so obviously we need a soldering iron and some solder itself, and we'll be doing a couple of electrical connections. Now, the safest way to do this is by using the U-shaped connectors and obviously a crimping tool to make this work. You can wire them straight into the terminals themselves, but as I say, I always prefer to go to the safest option, which is using these type of connectors, and obviously a few tools such as wire strippers and wire cutters to make all of this possible. So let's take a look at what this setup actually is. Now, on the left hand side we have the spindle. These typically come in two types, an air cooled and a water cooled. Whilst water cooled is typically considered better, they can sometimes have a little bit of extra weight, so you need to factor that in. If you are looking at one and unsure what kind it is, take a look at the top of them. If it's got vents, it's an air-cooled spindle like this one here. If it's got two extra spigots coming off, it's a water-cooled spindle, obviously to allow the water to go in and come out. Now, in terms of the power of these spindles, when referencing them for desktop machines, you'll typically see three different power variations: a 0.8 kilowatt, a 1.5 kilowatt and a 2.2 kilowatt. The one we're using today is the 1.5 kilowatt, sitting right in the middle, but obviously 0.8 is less power, a 2.2 would be more power. Now, the device on the right hand side, this is the VFD, the variable frequency drive. Now, I'm not going to explain how this works, but the easiest way to try and think about it is ultimately this controls the power delivery to the spindle in a much more consistent and controlled way, therefore getting much better results in the spindle even if you are cutting through heavier, harder material. Now, in terms of the VFD, similar to the spindle, these have different power ratings. You need at least the same rating as your spindle, if not more. So in this scenario, my spindle is 1.5, but the VFD is actually rated at 2.2. It is always better to be able to deliver more power than not enough power. Now, the VFD itself has a little display control unit at the front. In essence, this is basically for turning the spindle on and off, controlling the speed that it is running at, and also setting some other program functions on it if you are linking this up to other devices. Now if I flip this over and lift this hatch up here, we'll see we have a couple of different electrical connection sections. The one at the bottom is the main one we're going to be focusing on today. This is all about the power in and the power out. The left hand side is about the power coming from our circuit in order to run all this and power it up. The right hand side is about the power coming from this device going to the spindle, and we'll dive into that in a moment. The connections on top are to help other things, as I say, such as if you are connecting this via a serial port, or the different types of means of communications for powering this on or running different programs. There are lots of options. I'm not going to go through them in this video because this is simply about wiring it up in its simplest format. Now, whilst I don't want to scare anyone, I do need to point something out. Some of the cheaper manufacturers went through a phase of not grounding these spindles and ultimately making them quite dangerous to use. Now, read the instructions or check the website and see if it references anything to do with an earthing terminal as part of the connection or a grounding connection. If you can't see anything in the instructions, potentially take the top off like I have done here and look for something that is essentially connecting the top part through to the metal body itself, like this little ring connector that we can just about see here. And this just guarantees, as I say, that everything should be earthed and able to run safe. And ultimately, when you come to put it back together, obviously remember to make sure it is all put back in the same place. So the first thing we're going to do is simply cut the end of this off. We're then going to remove the outer coating to expose the 3 wires underneath. So let's get that done now. With the outer coating removed, we're now going to take probably just under 1 centimetre off the end of these to expose the copper wiring underneath. And then we're going to crimp on a couple of these U-shaped terminals onto the end of each wire. Those 3 are now done. We'll move on to the other cable. So we're going to do a similar thing and trim back a couple of inches of the outer sheathing, but do remember this is shielded cable, so you'll need to cut through the outer layer, then remove the shielding as well before exposing the wires inside. Make sure obviously not to trim through straight through the shielding into the wires. So we'll get this done now and get this stripped back. So with that removed, do just go back to where you cut it and check that you didn't pierce any of the cables underneath. Make sure they are all intact. These are probably a fraction long, so I'm just going to cut a little bit off the end of them. And then again, we're going to come in and expose about 1 centimetre or so on the end of each cable. And we'll get 4 more terminals out and get these crimped all up. So that's this cable finished off. Some people do like to put shrink tubing wherever the cable has been cut just for some extra protection, but I'm happy with how this is now. Now the other end of this cable we have also got to prepare in a similar way, but we're not going to be putting the crimp connectors on. We are going to be soldering it to this connection that goes directly to the spindle. Now you should have one of these in your kit. You should be able to unscrew it and take the cap off it. And inside you will see 4 terminals where we are going to solder the 4 wires to. But first let's take a closer look at this because there are a few important things we need to factor in. Now at this distance the camera doesn't really see it well, but each of these holes are marked up with a number. I'll put a picture on screen now to try and give a clear indication. And what these basically need to do is correspond to the connections on the VFD, which are marked up U, V, W and earth. Now you want number 1 to go to U, number 2 to go to V, number 3 to go to W and number 4 to go to earth. Do obviously remember that if you only have numbers on one side of the terminal, as you flip it over it will be on the opposite side. So for example, number 1 is on the right hand side top corner here. When we spin it round, number 1 will be on the top left corner. So you can see on this connection here it has a stress clamp. Now ideally, in order to make that stress clamp work, because it should go to the outer coating of this cable, you would only expose maybe 1 centimetre of cable underneath, possibly ½ inch at most. Now in order to only expose that small amount of cable and still solder 4 separate terminals, well that is quite a skill and not a skill that I'm confident I have. So I am going to expose more cable to make my life easier and then use something like shrink tubing to go back around that section where the stress clamp will go in order to give it more support. Now in terms of what colour cable should go to what number on the terminal, there probably is a correct method to do this, but I've watched several videos and to be honest nearly every one I've watched has a different colour coding of cable and they have gone in different orders. So it is as simple as this. Just make sure that it matches up end to end. So for example, if you solder brown to number 1, make sure brown at the other end goes to U, and the same with V and the same with W. Now the only exception I would say is the earth cable. That should always go to number 4. From everything I've seen, the 4th connection on those terminal is always for the earth, so we're going to make sure that one goes to earth. So brown is going to go to U, black is going to go to V, grey is going to go to W, and the earth is going to go to the earth. Soldering these cables to those small terminals is not the easiest of process, especially if you're not overly confident with soldering. So what I would suggest doing is simply tinning in your cables, getting a bit of solder in the end of each one, also doing the same on the terminals, heating those up, getting a bit of solder into them, and then simply heating them both up together, touching them, and it should fuse that bit of solder together and hopefully hold the cables in position. And again, you may want to put a small piece of heat shrink wrap on each cable to slide over the terminal once it is done. So I rarely have to solder and therefore my skills are not very good, but what we have here is each wire has a bit of solder on the end of it and each terminal here also has a bit of solder on it. Now in theory we should be able to push them together, heat them up, and as I say, it should bind them both together nice and secure. So it's not perfect, but for my level of skill I'm happy with that. Each cable is held securely and there's a clear gap obviously between every connection, which is exactly what I wanted. I did overcook the cable slightly and therefore some of the shrink tubing has shrunk obviously before I've been able to slide it in place. So I'm going to see if I can get around that one way or another, but overall happy with that job. So fortunately I was able to cut off the tubing that had shrunk and able to slide the excess back over the terminals. Ideally I would have preferred a little bit more on this, but at least every terminal is now covered and connected and we can heat this up, shrink all those together and finish off this connection. Now don't make the same mistake I did. I spent so much time worrying about the soldering and the connection that I forgot to put the clamp and the housing on the wire before we started. So hopefully I can get this back on from the other end and not cause myself any issues. So it's taken a little bit of work, but we've got this all in place and secured now, and we can go away and connect this to the spindle itself. As always, I will try and keep this part as simple as possible. If you are familiar with wiring things up, you may be used to letters such as L, N, E, live, neutral, earth or ground. Now on here we will see R, S and T, and this may be slightly confusing to you. These VFDs can run off single phase or 3-phase electricity, so it is labelled up for 3-phase, but basically your instructions should tell you somewhere which ports to use if you are just using single phase like we are today. And mine clearly says underneath use R and T. Now I have seen elsewhere that basically, from what I understand, you can use any 3 of these ports, but if your instructions give you specific directions such as mine for using R and T, that is what we're going to do today. So we're going to put the brown into the R connection, we're going to put the blue into the T connection, and then we're going to put the earth into the ground connection in the middle. So now with the other cable as well, we're going to connect this up. The same scenario as before, the earth will go to the earth. We said the brown was number 1, so that will go to U. The black was number 2, so that will go to V. And the grey was number 3, so that will go to W. So we'll get all these in place now and tighten and secure everything up. So there we are, all the cables are in place. We do have 2 earths going into the same terminal, but that is absolutely fine. Now one thing I will mention is technically you should also earth the shielding in this cable. I'm not doing it in this video because it is just a temporary setup for the moment, but when I come to do this permanently, I will shield this earth. All you simply do is cut back some of the casing, expose the earth in, and then essentially connect that separately to the earth as well, just to guarantee that everything is as safe as possible. Now when you come to connect these up, there is a little notch in the end of the connector which will align with a protruding part on the inside, just to guarantee the connection sits the right way around. And then get that in place, make sure it aligns and slides in, push it in tight and screw the connector down until it is tight and held in place, and then we're good to go in doing a dry run with this spindle. So in that last clip, I very specifically said a dry run. Now the reason for this, there's no point in connecting it all to your machine and finding something isn't working. So we're just resting the spindle in the polystyrene that it came, and I've just propped this up so hopefully you can see it. Now I have deliberately taken the collet insert and the collet nut out. Either take it out completely or tighten it up all the way. Basically you just don't want this coming loose when we start the spindle up. So in theory we should turn the power on and this should come to life. The audio might change a little bit, obviously the fans will kick in, so let's see how we go. So it will take a few seconds essentially for the VFD to do a bit of a startup procedure before it is good to go. What you should just be able to see on screen at the moment, hopefully, is it is flashing 400. Now the easiest way to think about this is 400 is full power. It's the frequency that it's running at, but basically it means that at 400 this will run at its maximum speed, which is 24,000 RPM. So at 200 this would run at half power, 12,000 RPM. And obviously at 0 there would be no power at all, so it wouldn't be rotating. So whilst may seem an odd number, easiest way to think about it, as I say, is 400 is maximum power. Now instead of starting this up at 400, I'm going to bring this down to a slower speed just to test it initially. We simply hold down the down button and we'll take a few seconds. I want to bring it quite low because I don't want it starting up too fast to begin with, maybe about 120, something like that. We got a bit too far there, but yeah, it's close enough. So there we are, I've got it to 120 now, and it should start up without being too fast. The other thing I will point out about these setups in comparison to a normal spindle you get on your desktop machine, these will start up slowly. We can control how fast it builds up to that speed later on in the programming of this, but for the purpose I'm going to leave it as the default, and we're simply going to click run, and hopefully that should start to spin. You should see this build up as well from 0 and gradually, as I say, speed up to 120. So let's go. Now whilst that's speeding up, if you have found the video useful, remember to hit like and that subscribe button in the corner. There we are, that's now running at a frequency of 120. We can hear that running in the background, so I'll click stop now and let this slow down. Don't know if the camera will pick it up, but as this slows down, keep an eye on the direction the collet is spinning. Hopefully you were able to see that it was spinning in an anti-clockwise direction from the from the angle that we're looking at it. Now that is the correct direction. If I lift this up, you should just see the arrow there is pointing that way. So fortunately that is turning the correct direction for the spindle and ultimately for the cutting that we're doing. Now if for any reason yours runs the opposite direction, what you simply need to do is swap two of the wires over from the VFD, from the Spindle VFD cable. It can be any two wires, just swap them over and it will then spin the correct way. Now I briefly mentioned about the acceleration of this building up quite slowly, and ultimately we can adjust that to make the spindle start much faster. So I want to show you how to do it on mine. Obviously everyone may be different, so do check your instructions specifically on how to do your particular model. So in this one what we're going to do is click the set menu in order to enter the program number mode. We're then going to go up to number 8. Number 8 in the instruction manual is for acceleration. And then we're going to press set again to enter that. Now by default this is at 50, so I believe that takes 50 seconds to get from 0 to full speed. Obviously that's quite a long period, so we're going to bring that down. That's just jumped back out of the menu because I took too long, so we'll enter back into it. So I want to bring this down to about maybe something like 5 seconds. I want it to speed up quite quickly. So there we are, that's on 5. I'll now press set to confirm that, and then we'll press stop to exit the menu. Now in theory when I press run, this should speed up much quicker to the desired speed. There we are, almost instant to get to the speed I required it at. Click stop. What we can see is the deceleration now is quite slow. And again, we could go in and adjust that setting if we wanted to. On the menu, deceleration was menu 9. So I'll wait till this stops. What I'll then do is go into set, Go into menu 9, click set again, and again that's on 50. So we're going to bring the deceleration right down. I don't want it to be quite as fast as the acceleration. I'm happy for it to slow down a little bit slower essentially. So maybe leave this at a few seconds. So the deceleration is now at 6. So we'll confirm that. Click stop to clear the menu. Now in theory again, when I press run, it should speed up quickly, and it should also decelerate faster when I press stop. Up to full speed, deceleration, stop fairly fast. So there we have it. That's how easy it is to change some of the parameters in these VFD setups. Let's move on now to installing this into the machine. So the next step is obviously to install the spindle onto the machine. We're going to get rid of the existing spindle, put the new bracket in, and then drop the big spindle into that and get everything ready. So the spindle is in place. The connection has been made back to the top of the spindle. The VFD has been temporarily mounted to the wall. This is not going to be its home, it's just for now for the purpose of this video. I still need to support the wires underneath, but ultimately, well, this is pretty much everything done. So let's just check everything is still running. Perfect. That's your spindle and VFD installed and running. So I'm not going to round this video off and say how easy was that, because there were some tricky parts within it. But obviously if you are comfortable doing electrical connections and some soldering, you should get through it fine, as long as you take a couple of safety precautions whilst you are doing everything. Now if you did find this video useful, as always, please give it a thumbs up and make sure you subscribe to the channel. It really does help me out. I will put some links to various Spindle and VFD setups in the description area below if you want to check them out, but that is everything for today's episode. Thank you very much for watching. Final thanks as always goes to my patrons. If you want to get involved for early access to content, one-to-one help and giveaways, then definitely check out the Patreon links. I will see everybody on the next episode.